Welcome back to The Deep Dive. We're the show that really tries to cut through the noise and get you the insights you actually need.
That's the goal.
And today, we're jumping into something that honestly seems to trip up a lot of folks. The difference between power inverters and generators.
Oh, yeah. Those terms get thrown around interchangeably all the time.
Exactly. And it leads to this kind of fuzzy picture, doesn't it? You're not really sure what does what, or more importantly, what you might need for your situation.
Mm-hmm. Very common confusion.
So that's our mission today. We want to bring some real clarity here. We're going to look at three main types. You got your classic traditional generator.
The workhorse.
Right. Then the inverter generator, which, let's be honest, is probably what most people mean when they say power inverter for backup power.
Usually, yes, in that context.
And then the third kind, the standalone battery-based power inverter. So by the end of this, you should have a really solid handle on how they work, the costs, efficiency, best uses, all that good stuff.
Right. And we should mention, we're drawing heavily from a pretty detailed comparison report for this. It lays out the specs and differences quite clearly, which gives us a great base.
Excellent. Okay, so before we get into the performance details and the costs, I think we need to just pin down what these things are fundamentally.
Absolutely. Foundational stuff. Because once you get how they work, the differences make a lot more sense.
Exactly.
Okay, so let's start with the traditional generator. The simplest way to think about it is it's a device that burns fuel, usually gasoline, sometimes diesel or propane, to turn an engine. That engine spins an alternator and boom, you get electricity. Specifically, alternating current, or AC.
AC, like what comes out of the wall socket.
Precisely. And a key thing here is the engine runs at a constant speed. Usually pretty fast, like 3,600 RPM.
Non-stop, full tilt.
Pretty much. Doesn't matter if you're powering one light bulb or your whole fridge, the engine's running at that same speed. It's a very direct mechanical setup.
Okay, straightforward. Engine burns fuel, makes electricity. Got it. Now, the inverter generator. This is where the name confusion really comes in, right?
This is exactly it. Because it has inverter in the name, people sometimes shorten it or confuse it with the other type of inverter.
So what makes this one different from the traditional? It still burns fuel.
Yeah, it does, yes. It still has a fuel-powered engine, just like the traditional one. But here's the clever bit. It uses inverter technology. The engine generates AC power first, but then that power gets converted into direct current DC.
Right.
And then the inverter circuitry converts that DC back into AC, but it's a very clean, very stable AC output.
So it's like a two-step process. Make AC, convert to DC, then convert back to clean AC.
Exactly. That's the core difference. And another huge thing, its engine speed isn't constant. It adjusts based on how much power you're actually drawing.
Oh, interesting. So it can idle down if you're not using much power.
Precisely. Which, as we'll see, has big implications for fuel efficiency and noise.
Right. Okay. So we have generate direct AC and generate AC convert to DC convert back to clean AC. What of the third type? The standalone power inverter. No engine here.
No engine at all. This is purely an electronic device. It doesn't generate power from fuel. Its job is simply to take existing direct current DC power.
Like from a battery or solar panels.
Exactly. Takes that stored DC power and converts it into usable AC power for your appliances. That's its sole function. DC to AC conversion. It needs that external DC source to do anything.
Got it. So generator makes power from fuel. Inverter converts power from DC to AC. And the inverter generator kind of does both.
That's a good way to summarize it, yeah. Understanding that fundamental difference-making versus converting is really key.
Okay, that distinction alone clears up a lot.
Yeah.
And knowing the mechanics, well, that really sets us up for the next part. This is where it gets really practical for people, right? The stuff you actually notice.
Mm-hmm. The user experience.
Let's talk about power output, the raw wattage. How do they stack up?
Well, if you need sheer grunt, traditional generators are usually the kings. They can put out a lot of power. Portable ones can go up to, 20 kilowatts or even more sometimes.
Wow, 20 kilowatts. That's enough to run some serious stuff.
Oh, yeah. We're talking whole home central air conditioning, well pumps, big power tools on a job site, heavy loads.
Okay, so traditional for the heavy lifting. But I guess more power isn't always better, or maybe not always necessary. How do inverter generators compare?
Right. Inverter generators typically have a lower maximum output. You're often looking at maybe 1 kilowatt up to, say, 10 kilowatts.
So less peak power generally?
Generally, yes. Though an interesting feature is that you can often parallel them. You can connect two identical units together with a special cable and basically double your available wattage. So 2 3 kW units could give you close to 6 kilowatts.
Ah, okay. So there's some flexibility there.
There is, but the real advantage, going back to how they work, is the quality of the power. Very stable, very low, total harmonic distortion, or THD, usually under 3%.
THD, that's the cleanliness measure we talked about.
Exactly. Lower THD means cleaner power, safer for sensitive electronics.
We'll definitely circle back to why that matters. What about the standalone inverter's output?
That really depends. Smaller ones might only offer 300 watts, enough for a laptop or some lights. Bigger ones can go up to 5 kilowatts or more. But the crucial limitation is the battery. Your output is limited by what the battery can deliver and for how long. Great for lower or medium loads, but sustaining high power needs a big battery bank.
Right, the battery capacity is the bottleneck there. Okay, so power output is one thing, but anyone who's been near a generator knows the next big factor: noise.
Oh, absolutely. Huge difference here. Traditional generators, they're loud, period.
Like vacuum cleaner loud, lawnmower loud.
Yeah, 60 to 90 decibels is pretty typical. It's a constant drone, really disruptive for camping. Or in your backyard during an outage. Forget having a quiet conversation nearby.
I can attest to that. Trying to chat over one at a campsite is not fun.
It's probably the #1 complaint, honestly. It makes them pretty unwelcome in quiet neighborhoods or parks.
So how do the inverters compare on noise?
Big improvement. Inverter generators are significantly quieter, typically in the 50 to 60 decibel range.
So more like normal conversation level, or maybe a quiet AC unit.
Exactly. Much, much more neighbor-friendly. Way better for camping, RVs, tailgating, or just running backup power at home without driving everyone crazy.
That's a massive difference in usability.
Yeah.
And the standalone inverter.
Silent. Essentially silent. No engine, no combustion. You might hear a small cooling fan on some models, but that's it.
Wow. Okay. Silence is golden, as they say.
Especially if you need power indoors for brief periods or in really noise-sensitive areas.
So noise is a clear win for the inverters, especially the standalone. Now let's revisit that power quality thing, the THD. Why is dirty power from traditional generators a problem?
Okay, this is super important, especially today with all our electronics. That high THD, maybe 5% to over 20% from traditional units, it means the electrical waveform isn't smooth. It's got spikes, dips, irregularities.
And that can damage stuff.
It absolutely can. Sensitive electronics, laptops, smartphones, TVs, gaming consoles, medical equipment, they're designed for clean, stable power like you get from the grid. Feeding them dirty power can cause malfunctions, shorten their lifespan, or even fry them outright.
So it's not just about, like, the lights flickering. It's a real risk to your expensive gadgets.
A very real risk. It might not happen instantly, but that unstable power can degrade components over time. It's like feeding your high-performance car bad fuel.
Okay, that's a good analogy.
Yeah.
So inverter generators with their low THD.
Much safer. That sub-3% THD mimics grid power very closely. It's clean power, safe for absolutely anything you'd plug into a wall socket. This is a major, major selling point for inverter generators.
And standalone inverters. Also clean.
Generally, yes. They produce very clean, stable AC. The quality can depend a little on the inverter design and the health of the battery providing the DC, but typically it's very good quality power.
Right. One last practical point. Portability. Getting these things where you need them.
Yeah, definitely a factor. Traditional generators, because of the engine's size and frame, tend to be bulky and heavy. We're talking 100 pounds easily, up to 300 pounds or more for the bigger portable ones.
So not something you just casually toss in the car trunk.
Not usually, no. Often needs 2 people or a dolly to move around comfortably. Inverter generators, however, are generally designed with portability in mind.
Lighter. More compact.
Much lighter and more compact, typically. Anywhere from, say, 20 pounds for a small one up to maybe 100 pounds for a larger model. Often have handles, sometimes wheels. Much easier to transport for camping or tailgating.
And the standalone inverter must be the lightest.
The inverter unit itself, yes, definitely. Can be handheld or suitcase-sized, super portable. But you have to remember the batteries.
Ah, right. The batteries add the real weight.
Exactly. Depending on the capacity you need, the battery bank can be quite heavy and bulky, potentially outweighing the inverter itself. And if you add solar panels, the whole system's portability needs careful thought.
It really highlights those trade-offs, doesn't it?
Absolutely. What you gain in one area, like the raw power of a traditional generator, you often sacrifice in another, like noise or power quality. And the quiet, clean power of an inverter might come with a lower peak output. It's all about priorities.
That's a perfect segue, because understanding those trade-offs directly impacts the longer-term picture, your wallet, the upkeep, and the environmental side. Let's dig into efficiency, cost, maintenance, and environmental impact, starting with fuel efficiency.
Okay. Traditional generators are not very fuel efficient because that engine runs full tilt all the time.
Right, even if you're barely using any power.
Exactly. It burns fuel inefficiently under light loads. You might only be getting, say, 40% actual efficiency from the fuel you put in. Lots of waste.
Which means you're burning through gas faster, spending more money.
Definitely higher fuel costs over time. Inverter generators, because they adjust engine speed to the load.
They sieve fuel when demand is low.
Precisely. They only ramp up when needed. This makes them way more fuel efficient. You could see fuel savings of like 40% or even 50% compared to a traditional generator running the same load for the same time.
That's huge, especially with gas prices.
It makes a big difference in running costs. And standalone inverters, well, they use zero fuel.
Can't beat zero.
Right. They run off the stored battery energy. So runtime is limited by battery capacity unless you have solar recharging. With enough sun, you could potentially run indefinitely, theoretically, but heavy loads will drain batteries fast without constant strong input.
Okay, let's talk the big one. Cost. Upfront investment.
Traditional generators are usually the cheapest upfront. That simple mechanical design keeps costs down. You can find decent ones, maybe 2 kilowatters to 10 kilowatters, for anywhere from, say, $300 up to maybe $2,000.
Pretty accessible price range for basic power.
Yeah. Inverter generators, with that extra tech inside the inverter board, the variable speed controls, they cost more. For similar power output, you're looking at maybe $500 to $3,000, sometimes even more for high-end models.
To a noticeable jump in price for the quieter, cleaner power.
Definitely. And repairs can be pricier too, if that complex inverter board fails, for example. Standalone power inverters. The inverter unit itself might be $100 for a small one, up to $1,500 or more for a powerful, pure sine wave model.
But that's not the whole cost picture, is it?
Not at all. You have to add the cost of the batteries. And good deep cycle batteries aren't cheap. Depending on the size of the bank you need, batteries can easily cost as much or significantly more than the inverter. Add solar panels, and the total system cost can climb quickly.
So while there's no fuel cost, there's the upfront battery cost and eventually replacement costs for those batteries.
Exactly. Batteries degrade over time.
Which brings us to maintenance and reliability. What's involved in keeping these running?
Traditional generators need the most regular TLC. They're combustion engines, so think oil changes, spark plugs, air filters, fuel stabilizers, regular engine maintenance. They can be pretty rugged, but like any engine, they need upkeep to stay reliable.
Standard engine stuff. How about inverter generators?
They still have engines, so they need similar basic maintenance oil, filters, etc. Maybe slightly less frequent because the variable speed means less wear under light loads, but they add that layer of electronics. If the inverter part fails, repairs are usually more specialized and costly.
So maybe less mechanical wear, but potential for more expensive electronic failures.
That's a fair summary. Standalone inverters are the lowest maintenance by far. No engine, no oil, no fuel system, maybe keep the vents clear, check connections. The main thing is battery care and eventual replacement. Batteries typically last, 2 to 10 years, depending on the type and how you use and charge them.
Okay. And finally, the environmental impact. This is a bigger deal for many people now.
Huge deal. Traditional generators have the biggest impact. They burn fossil fuels, produce significant emissions, including dangerous carbon monoxide, CO, plus noise pollution. That CO risk is why they absolutely must run outdoors, far from windows and doors, like 20 feet minimum.
Seriously important safety point there.
Critical. Inverter generators are better. Because they burn less fuel more efficiently, their emissions are lower. Still produce CO, still needs safe outdoor operation and good ventilation, but definitely a step up environmentally from traditional ones.
More eco-friendly, but still requires caution.
Absolutely. The clear winner environmentally is the standalone inverter. Zero emissions during operation. If you pair it with solar charging, it's about as clean a power source as you can get. No fuel, no fumes, no CO risk from the unit itself.
It really paints a clear picture of the trade-offs across the board: efficiency, cost, upkeep, environment.
Exactly. It's rarely a simple choice. What you value most, budget, quietness, power quality, sustainability, really guides you to the right type.
Okay, we've unpacked the how and the what. Let's bring it home for you, the listener. Based on everything we've discussed, when should you choose each type? What are the best use cases? Let's start with the traditional generator.
Right. Choose a traditional generator when raw power and budget are your top priorities and noise or perfect power quality are less critical. Think construction sites running lots of tools.
Workshops, maybe.
Workshops, absolutely. Or for emergency whole home backup if you need to run really heavy loads like central AC or a well pump, and you're okay with the noise and taking precautions for sensitive electronics.
So brute force power for tough jobs or big loads, especially if cost is tight, what are the main downsides again?
Loud, inefficient, especially under light loads, that dirty power risk to electronics, and higher fuel consumption. It's a workhorse, but not a refined one.
Okay, now the inverter generator. When does that make the most sense?
Inverter generators are your versatile all-rounders. They excel when you need quiet operation, good fuel efficiency, and clean power for sensitive gear.
Like camping.
Perfect for camping and RVs. Also great for home backup for essentials, fridge, lights, computers, medical devices, tailgating, small outdoor events. Anywhere, noise and power quality matter.
So quieter, cleaner, more efficient power for everyday uses or sensitive stuff. Drawbacks.
Higher upfront costs is the main one. Generally lower maximum wattage compared to the biggest traditional units, and potentially more expensive electronic repairs down the line.
So the recommendation is, choose this if quietness, efficiency, and protecting your electronics are key, and you're willing to invest a bit more upfront for that versatility.
That sums it up well. It's often the best balance for general home backup, recreational use, and protecting your gadgets.
And finally, the standalone power inverter paired with batteries. Who is this for?
This is for situations where silence and zero emissions are non-negotiable, or you're integrating with solar. Think short-term backup for just essential small devices, phones, laptops, maybe a CPAP machine.
Off-grid cabins with modest needs.
Ideal for that, yeah. Or inside use during an outage where fumes are totally unacceptable, maybe very noise-sensitive environments.
Main limitations.
Limited power output and runtime without a big and expensive battery bank. Recharging takes time unless you have significant solar input. Not really suited for running large appliances for extended periods.
So choose this if you want a fuel-free, silent, eco-friendly option, primarily for lower power needs or short durations, and you understand the battery capacity limits and costs.
Exactly. It's great for specific uses, especially if paired with renewables, but it's not usually a direct replacement for a generator for, say, whole home backup during a long outage.
It really comes down to matching the tool to the job, doesn't it?
Precisely. And thinking beyond just the specs. What's your specific scenario? What do you value most? Raw power, quiet, cleanliness, budget, sustainability. Answering those questions is key. And I just want to reiterate that safety point. Any generator burning fuel, traditional or inverter, makes carbon monoxide. Operate them outdoors, far away from your house. Seriously, look for models with CO sensors and automatic shutoff. It's a lifesaver.
Absolutely critical advice.
Also, consider portable power stations. Many of these integrate a battery and an inverter, sometimes solar charging too. They can be a great middle ground, offering some of the benefits of standalone inverters with more plug-and-play convenience for certain uses.
Good point. Lots of options evolving there.
Okay.
So let's wrap this up. We've really dissected these three distinct power players. You've got the powerful, no-frills traditional generator,
The workhorse.
the refined, quiet, and efficient inverter generator,
The versatile choice.
and the silent, zero-emission standalone power inverter running purely on stored energy,
The clean option.
each with its own distinct advantages and disadvantages.
Definitely. So when you're making your choice, think hard about your specific needs. Is it the rugged demands of a job site, the quiet comfort needed for camping, or maybe the silent, clean backup for just your essential gadgets? Let your priorities guide that decision.
And maybe a final thought to leave you with. As we all rely more and more on electricity, and as things like sustainability become, well, increasingly important, how do you see these technologies evolving? Will we see even smarter, more integrated solutions blending generations, storage, and clean power right in our homes, or even in portable forms? Feels like things are definitely moving in that direction.
It certainly does. The future likely holds more hybrid systems, better battery tech, and smarter energy management. It's an interesting space to watch.
Definitely something to chew on. Thanks for tuning into The Deep Dive.